Today's lesson is on rational exponents. By the end of this lesson, you should be able to change fractional exponents into radicals and vice versa. When you first learned about exponents, they were always positive integers and just represented by repeated multiplication. And then we had to go and introduce negative exponents, which really are represented by repeated division. Today, we will introduce rational or fractional exponents and extend your exponential knowledge that much further. So exercise 1, recall the product property of exponents. So what do? We multiply the exponents. So this one we get 5, and we're multiplying these, so we get negative 10. So the next one, well, what's 7 times 0? We'll multiply them, we get 3 to the 0, which we already know that answer is 1. And the next one, holy cow, what do? Well, we start with the outermost, so we multiply these. So I have 4 squared to the negative 4, and now I multiply those. So I have 4 to the negative 8. Now A and C are both going to be repeated division because they're negative exponents, which means negative exponents means they are fractions. So we will now use the product property to extend our thinking of exponents to include unit fraction exponents, those in the form of 1 over n, where n is a positive integer. Consider the expression 16 to the 1/2. Apply the product property to simplify 16 to the 1/2 to the 1/2. What other number squared yields 16? So if I do the product property, that means I need to multiply these. So 16 to the 1/2 squared is just 16 to the first, or 16. So what other number squared gives me 16? 4 squared gives me 16. You can now say that 16 to the 1/2 is equivalent to what more familiar quantity? So 16 to the 1/2 equals what? Well, let's think about this. If I can replace 4 squared with 16, that means I have 4 squared to the 1/2 squared. Correct? In that first problem. So I notice what happens to these two things. They cancel. So I just have 4 and then it's squared. So if I have a 1/2 power, what am I really doing? So 16 to the 1/2 gives me this number. So anything to the 1/2 power means what? So anything, let's write this one down. Anything to power or exponent of 1/2 means square root or radical. Okay? Oh, look, I wrote it in giant bold. This is remarkable. The exponent of 1/2 is equivalent to the square root of a number. And it's very, very, very important that you just see and know that. Okay? So, now let's practice in exercise 3. Can you do this without me? I certainly hope so. So pause the video and try on your own. Can you get 25 to the 1/2, 81 to the 1/2, and 10 to the 1/2? If 1/2 is equivalent to a square root of a number. Pause and go. So you should have gotten 5 for an answer, 9 for an answer, and 10 for an answer. Again, that highlighter, it's very, very important that you notice b to the 1 over n equals n root b. So that denominator becomes the index. And the index is right there. Okay? All right. Exercise 4. Rewrite each of the following using roots instead of fractional exponents. Then, if necessary, evaluate using your calculator to guess and check to find the roots. Don't use the generic root button. Check your calculator. So we've talked about what 1 over 2 means, square root. So I wonder what 1 over 3 means. So the formula on the other page said b to the 1 over n equals radical with our n is in, that's the index, b. So this really means 3 125. So this means cube root with a 3 on the bottom. Now, if you don't know how to use your calculator, let's show you. So when we have powers that are squared, we use this squared button, and that's a square root above it. When we have other powers, we use this caret button, so the button above that undoes any power. So this does any root, and you can see that the n is there. So we're going to do Control caret button, and I've got to go back big for you to see. So I'm going to put 3 in for the index, and then 125 inside, and that's called the radicand. And my answer is 5. So the cube root of 125, or 125 to the 1/3, is 5. So in part B, we have to the negative 1/2. Let's first deal with the negative. So we have 1 over 9 to the 1/2. Can't have negative exponents. We have to make them positive. So that gave us a fractional. Now we have 1 over the square root of 9. I don't have to put a 2 there because I know if I just use a square root button, so 1 over square root of 9, those are the same thing, okay? So the square root of 9 is 3, so I know that this is 1 over 3, or 1/3. I could plug the original in my equation, and I would see that they match. So why don't you try rewriting C and D and finding the answer, and then verify with the calculator. Pause the video and give that a try. So hopefully you got part C and D correct. Exercise 5. Let's think about the expression 4 to the 3/2. Fill in the missing blank and then evaluate this expression. So they told us it has to be raised to the 1/2. So I know whatever I put in here, if it has an exponent, I have to multiply it by 1/2. So what can I multiply 1/2 by to get 3/2? Hopefully you said 3. So 4 to the 3rd raised to the 1/2 is 4 to the 3/2. Hopefully you agree. So 4 to the 3rd, 4 times 4 is 16, times 4 is 64. 64 to the 1/2 means the square root of 64, which is 8. So fill in the missing blank and then evaluate this expression. Ooh, what if they gave me the 3 on the outside? What do I multiply 3 by to get 3/2? Hopefully you said 1/2. So now I know 4 to the 1/2, or the square root of 4 to the 3rd, is 2 to the 3rd, which is also 8. So it didn't matter which way I did it. So verify both using your calculator. So grab your calculator and put 4 to the 3/2 in your calculator and make sure it's 8. So now let's evaluate in part D 27 to the 2/3 without our calculator. It doesn't matter which way we use. So let's use the first model. So if we have 27 to the 2/3, that could equal 27 squared to the 1/3. Ooh, I don't know 27 squared, so that might be too hard. So what if I used the second model? What if I used 27 to the 1/3 squared? Can I find 27 to the 1/3? Can I find the cube root of 27 and then square it? So what number 3 times gives me 27? Hopefully you said 3. So this is 3 squared, and 3 squared is 9. Go ahead and verify with your calculator that I didn't lie, or make the calculation error. Hopefully it worked. Now read the box below. So pause the video and please read it and look at it. So for the rational number m over n, we define b to the m over n to be the radical with n as the index and m as the exponent. Or we could have in parentheses a radical with n as the index and our base inside, and then it's all raised to the m, okay? So one of the ways I remember it is if you have this base, that this is the exponent over the index, okay? Exponent over the index, all right? And they're in alphabetical order. So if I just have b to the second power, then I just have 2 over 1. I don't have an index. I don't need an index. I just have an exponent. So remember, the top number is your exponent. The bottom number is your index and the radical. And we're not going to deal with negatives. We have to make those positive first. So let's try exercise 6. It says to evaluate each of the following exponential expressions involving rational exponents without the use of your calculator. Show your work, then check your final answers with the calculator. So 16 to the 3/4. We're going to rewrite it. So we have the square root of 16, but it's not a square root. Remember, the 3 is your exponent and the 4 is your index. So it might be easier to write it this way. So we have the 4th root of 16 raised to the 3rd. So what number? 4 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So this number is 2 to the 3rd. So 2 times 2 is 4, times 2 is 8. So 16 to the 3/4 is 8. Go ahead and check it on your calculator. Pause the video. Part B, 25. So 25, 3 is our exponent, 2 is our index. Well, again, I can't do 25 to the 3rd in my head, so maybe I want to rewrite it that I have the square root of 25, index of 2, raised to the 3rd power. You don't have to write that 2. So the square root of 25 is 5 to the 3rd power. 5 times 5 is 25, times 5 is 125. Pause the video and check. Negatives are always going to be harder. So negative, I want to make it positive first. So do 1 over 8 to the 2/3. So 1 over cube root of 8 squared. So 1 over 8 squared is 64. And then the cube root of 64, 4 times 4 is 16. 16 times 4 is 64. So the answer is 1 over 4. So you got to be good at your math facts. Or you really don't, because they're not going to give you numbers you can plug in the calculator because you have access to the calculator during the regions. So they're going to give you questions with variables in there. Haha, example 7 and example 8. All right, so let's use our properties. How can we simplify this? Yuck, yuck, yuck. So I want to make the exponents positive first. Who cares that it's an equation? They're just telling me to find the answer to this. So I'm going to ignore this part. So I'm going to rewrite x already has a positive equation. Y is to the 1/2. X is to the 3/4. Well, this y to the -2 is on the bottom. Well, I can't have negative exponents, so I'm going to move it to the top to make it positive. Notice when I had negative exponents on top, like in letter C here, this is really over 1 right now. I made it 1 over it, so I moved it to the bottom. So they flip-flop and become positive. So now let's do our math. So what exponent is on x? 1. So what do I do here? Well, I'm dividing. What do I do when I divide exponents? I subtract. So in my calculator, I'm going to do 1 minus 3/4. So x equals 1/4. And then, what do I do when they're next to each other? Well, I'm multiplying. So in my calculator, 1/2 plus 2 is y to the 3/2. So tell me, in this form, what is this problem? What does A equal? 1/4. What does B equal? 3/2. All right. Wasn't so bad, but we definitely had to use our exponent rules, which makes that sometimes difficult. So let's look at number 8. Write the expression in simplest form. Assume all the variables are positive. So, yuck, radicals. So I'm going to rewrite this as exponents. So the exponent is 6, the index is 3. So this becomes y to the 6 over 3. Well, that's y to the 2 over. This becomes 27y. And notice all those are to the first power. So they're raised to the 1/3. Times y. My exponent is 11/3. So careful with this one. 27y to the 1/3. I have to give this exponent to both parts. So 27 to the 1/3 and y to the 1/3. Well, this is all numbers. So 27 to the 1/3, or the cube root of 27, is 3. Use your calculator. So I have 3y to the 1/3 times y to the 11/3. So on top I have y squared, on the bottom I have 3, and then these are next to each other so I can add them. 1/3 plus 11/3 is 12/3, which is y to the 4th. Oh, got rid of the fractions. Now I have 2 on top, 4 on the bottom. Ooh, that's a problem. If I just subtract, I'm going to get a -2. That's not allowed. I have 2 on top and 4 on the bottom. So if I subtract, I have 2 left. Where are those 2 left? On the bottom. So on the bottom, I have 3y squared. What's left on top if there's nothing there? A 1. Oh, we might have to go over that one again in class. Good luck!